Hi, my dear students. Today I am going to explain gravitation, one more high weightage chapter. Gravitation related different model questions. Please concentrate, students. Now, here, gravitation, very first question. Two particles A and B having masses 3m and 4m. Yes, two particles masses 3m and 4m is given. These are separated at distance r is given. Ratio of gravitational force on A due to B to that of B due to A. It is easy only, students. Now, for example, this A and B, gravitational force of attraction on A due to B is nothing but right side here. What is gravitational force of attraction on B due to A is nothing but left side. So, gravitational force of attraction, you know very well, depends on masses of particles and their distance. Now here FAB equal to G m1 m2 by r square. Force on B due to A also same, students, G into 3m into 4m by r square. So FAB equal to FBA, the ratio is nothing but 1:1 only, students. So force on A due to B equal to force on B due to A magnitudes. Magnitude same but direction opposite, students. Vectors direction opposite. Next, two planets have their same average mass density. Very important, students. So acceleration due to gravity, small g capital G relation, G equal to capital G m by r square. So if mass is constant means acceleration due to gravity inversely proportional to r square. But here same average mass density same given. So in terms of density, G equal to G into mass is nothing but density into volume 4 by 3 pi r cube by r square. So r square here cancel, remaining 1 r only. So G is directly proportional to density into radius, students. So density constant means G is directly proportional to r. Mass constant means G is inversely proportional to r square. Please remember. Now here density constant given. So ratio of acceleration due to gravity is G1 by G2 equal to R1 by R2 only. Already radius ratio is given 2:3. So acceleration due to gravity is on the surfaces also 2:3. Second option given, students. Please remember this point. G is inversely proportional to r square, mass is constant. G is directly proportional to r, density constant. Please note down this point. Next, select incorrect statement. Read careful question, students. Incorrect. So polar satellites go around the poles of Earth in north-south direction. Yes, students. Time period of polar satellite is approximately 100 minutes. 100% true. Nearly. Polar satellites are high altitude satellites. No, students. Low altitude, students. Polar satellites is less heights only. Less altitude satellites. So actually low altitude satellite is correct, but here high is given. This is incorrect, students. Now incorrect only asking, option 3 is correct. So theory questions also important. Next one. The height at which acceleration due to gravity becomes 1 by 9 times of value acceleration due to gravity on the surface of Earth. So easy, students. Variation of acceleration due to gravity with height. Formula: variation of acceleration due to gravity with height G dash equal to G into r by r plus h whole square. R is nearly equal to h. So now here G dash is 1 by 9 times of acceleration due to gravity on the surface G equal to G into r by r plus h whole square. Normal simplification. G is cancel. Square take this side. 1 by 3 equal to r by r plus h. Just cross multiplication. R plus h equal to 3r. So from here h equal to 3r minus r, 2r, students. Given fourth option. Okay. Variation of acceleration due to gravity with height r is nearly equal to h. Remember one more formula here. Variation of acceleration due to gravity with height. For example, h is very much less than r is nothing but g into 1 minus 2h by r. Using binomial expansion, using binomial theorem, you will get this expression. Less height students, h is very much less than r, use this formula. H is nearly equal to r, use this formula. Now here in this case 2r is the answer. Yes. Next, a body of mass is m raised from surface of earth to a height h, which is equal to 1 by 5 times of radius of the earth. So for example, this is earth students. Let us consider a block of mass is m. It is raised to a height. This height is given 1 by 5 times of radius. That means 3 by 2 times of r. 1.5 is nothing but, yes, 3 by 2 times of r. Yes. Now question, what is the work done in doing this? So this massive object bringing from here to here, how much work done? So here work done in the form of potential energy. Work done W equal to final potential energy minus initial potential energy. So what is the potential energy? Block on the surface is nothing but, you know very well, initial potential energy is minus Gmm by r. What is final potential energy is nothing but minus Gmm by r plus 3 by 2 into r. That means here 5r by 2 students, 5r by 2. So what is the work done is nothing but work done W equal to final energy minus initial energy. So these two terms common is Gmm by r. So from here we can easily calculate final energy minus initial energy, minus of minus plus students. So work done W equal to, so Gmm by r is common. So here minus 2 by 5, here 1 only, minus into minus plus, 1 minus 2 by 5. 1 minus 2 by 5 is nothing but, you know, 3 by 5. 3 by 5 times of G capital M small m by capital R. So work done W equal to 3 by 5 G capital M small m by R. This equation multiplied and divided R students. So Gm by R square is nothing but, here this complete term, Gm by R square is nothing but small g. In terms of small g is given. So 3 by 5 times of small mgr students. It is given second option. Okay. So work done equal to change in potential energy here in this case. Students, if you feel here it is lengthy, for this shortcut students, if you want, just remember formula shortcut. So in these cases, what is the work done means? Work done W equal to mgh. So that means here height from the surface students, mgh by 1 plus h by r, where h equal to 3 by 2 into r students. Just verify here, mg into h is nothing but 3r by 2 by 1 plus 3r by 2 into r. So r is cancelled. Here it is 1 plus 3 by 2 is nothing but 5 by 2, 2 by 5. 5 by 2, 2 to cancel. So 2 to cancel is nothing but, here it is 3 mgr by 2 is cancel here 5. So that means 3 by 5 mgr direct only. 2 steps you can easily calculate. So if you want, please remember this formula students. Work done W equal to bringing object from the surface to any height or from one satellite to other satellite. Work done W equal to mgh by 1 plus h by r. H is nothing but height from the surface. Please remember. Clear? Yes students, important model. Next question. Geostationary satellite is moving at a height of 6r, where r is radius of the earth. What is the time period of another satellite whose height is 3r from the surface of the earth? For example, this is earth students, earth of radius is r. So geostationary satellite revolving 6r height from the surface of earth. You know geostationary satellite time period students. time period of geostationary satellite equal to 24 hours time period of the earth only, you know very well. So what is the time period of another satellite? From the surface to 3 hour height it is revolving. Just easy students, time period and position from the center of the planet. Now time period t square is directly proportional to r cube. Time period of geostationary satellite, let us consider t1, other satellite t2, whole square equal to r1 from the center students, from the center 7r by, from the center total 7r, other satellite from the center is 4r. This is very important, many students confusion. 7r by 4r whole cube. Now r is cancelled. t1 is 24 hours by t2 asking question equal to 7 power 3 by 2 students by 4 power of 3 by 2. Sir, 3 by 2 how it comes? Just square, take this side is nothing but power 3 by 2. Yes, 4 power 3 by 2 is nothing but 2 square, 2 cancel, 8 students. So now here t2 equal to, from here t2 equal to 8 into 24, 192 by 7 power 3 by 2, you can write 7 root 7. Any doubt? 7 power 1, 7 power 1 by 2. 1 plus 1 by 2 is 3 by 2. So 7 root 7. So time period t equal to, t2 equal to 192 by 7 root 7 hours. So it is given third option students. Very important students. Kepler's third law related many times repeated questions, NEET point of view. T square is directly proportional to r cube, multiple times question. Very important. Yes, next question. A planet is orbiting in an elliptical orbit around the sun. K is kinetic energy, U is potential energy, T is total energy, and L is angular momentum about the sun respectively. Okay. Then select correct statement students. Correct statement. Kinetic energy is remains, kinetic energy is conserved. K means kinetic energy is conserved. No students. Elliptical orbit. Elliptical orbit is nothing but distance less is nothing but speed is more, kinetic energy also more. So kinetic energy different places, different students. So kinetic energy remains conserved means wrong students. Kinetic energy continuously changing. Next. Potential energy always positive. No. Gravitational potential energy minus gmm by r. So it is always negative students. So always positive is given. Wrong. So E is always negative. Yes, E is total energy students. Potential energy negative, kinetic energy positive, total energy always negative. It is correct statement students. So total energy always negative is correct statement here. Correct only asking. L remains conserved but direction changes continuously. No students. So planetary motion, angular momentum of revolving planet around the sun remains constant students. So now here third option is correct. Total energy always negative, planetary motion. Next. Escape velocity from earth is 11.2 km per second if body is to be projected at an angle 53 degrees. Listen students, important, it is also many times question. Minimum velocity, escape velocity 11.2 km per second given, that means it is earth only. If the body is to be projected 53 degrees, escape velocity does not depend on angle of projection. If it is projected 37 degrees, 53 degrees, 45 degrees, whatever may be, it is 11.2 km per second remains constant only. Escape velocity under root of 2gm by r students, or under root of 2gr. So it does not depend on angle here. So 11.2 km per second, first option only correct. Yes, little easy question this one. Next. Dependence of gravitational potential V due to a hollow sphere of mass is m. Hollow sphere students. Hollow sphere potential on the surface maximum minus gm by capital R on the surface. Inside also potential constant students. What is the potential on the surface? potential inside remains constant only. What is potential inside is nothing but it is also minus Gm by R. What is potential outer point is nothing but from center to distance increases, from the surface to distance increases, potential outer point is minus Gm by small r, inversely proportional to r means decreases, but because of negative value here, so from center to here it is constant, students. On the surface it is constant only, on the surface to decreases, students, because of negative value decreases. So second option is correct. Okay students, very important, don't confuse potentials and intensity of gravitational fields. Gravitational field intensity inside 0, students. Okay, now here constant, don't confuse. Next question, if gravitational force of attraction between earth its satellite revolving around vanishes suddenly, okay, then which of the following is correct? Very important, students. See here, satellite is revolving around the planet. So here satellite revolving means two forces, centripetal force balances gravitational force of attraction between satellite and planet. Okay, so now what is given here, satellite revolving around it vanishes suddenly. For example, gravitational force vanishes, so that means here tangential force act in this direction. Because of gravitational force only it is completing circular motion. If it is there is no gravitational force is nothing but, so there is no center centripetal force, it is moving this direction only, tangential direction only. So here satellite will continue move orbit with same speed. No students, satellite will move towards earth vertically downwards. No gravitational force. Wrong, students. Satellite will move tangentially to the original orbit with same velocity. Yes, with same velocity direction, so it is moving tangentially along the direction. So third option is correct, students. If gravitational force vanishes, gravitational force of attraction, it is moving tangentially to the original orbit with same velocity. Students, very important. Next, if a body lying at 45 degrees latitude feels weightlessness, yes, so acceleration due to gravity with latitude formula g phi equal to g minus r omega square cos square phi. Phi equal to 45 degrees given. So weightlessness means g phi equal to 0 only. 0 equal to g minus r omega square cos 45 1 by root 2, cos square 45 is nothing but 1 by 2. Okay. Question here, what is angular speed of earth in this situation? Omega asking, students. Just here omega square r by 2 equal to g, omega square equal to 2g by r, omega equal to from here under root of 2g by r. So what is angular speed is nothing but under root of 2g by r. Fourth option is correct. Important model, students, very important. Next, gravitational potential at the center of square of side is L having 4 equal masses placed at the vertices of square. These model questions also important, students. All different model questions I am explaining for any entrance. Now here 4 particles each of mass m located 4 corners of square given of side is L. Okay. Question asking here, what is gravitational potential at the center? So one of the particle to distance is centroid distance, center distance here, sorry, center distance. So total according to Pythagoras law root L, half is nothing but L by root 2. I think you know very well. So what is potential means potential scalar quantity, students. What is gravitational potential at the center is nothing but all identical only. So that means multiplied with 4 into 1 of particle gravitational potential. So potential V equal to 4 into what is potential due to 1 of the particle is minus Gm by distance is L by root 2. So root 2 take up, potential V equal to minus 4 root 2 Gm by L, students. So minus 4 root 2 gm by L given fourth option. Yes. Same question if they ask gravitational field intensity at the center means 0 students, it is vector quantity, but potentially scalar quantity, normal summation only, scalar summation. Yes. Next question students, figure shows elliptical orbit of planet P about the sun. Yes. The shaded area SCD, SCD, okay, 3 times shaded area SAB. So this area of cross section 3 times more is given, 3A. Let us consider here it is A, then here 3 times more is given. So aerial velocity of radius vector remains constant, Kepler's second law. That means area of SCD by time interval. Let us consider here time interval delta T1 students. This time interval delta T1 equal to SCD. Area SAB by time, let us consider here delta T2. Aerial velocity of radius vector remains constant. Area of SCD given 3 times more than area of SAB given in the question. So 3A by delta T1 equal to A by delta T2. So A is cancelled here. Delta T1 equal to 3 delta T2. Delta T1 equal to 3 delta T2. So given option 3 students. Okay. So continuation problems. Next video I will explain. Really, if you like the video, please share and subscribe my channel students for more videos. Okay. Thank you students. Thank you so much.